Live streaming is on.
In this work, we are mostly focusing on the following set of tasks. First of all, we studied the features of epidemic algorithms in an untrusted environment. Secondly, we developed several ways to optimize the epidemic network protocol of the neo-blockchain network. And finally, we evaluated the efficiency of the proposed enhancements by simulating of the neo-blockchain network. To evaluate the efficiency of the network protocol, we used two metrics which are widely accepted. The first one is frame non-delivery probability. It shows the probability of event that a piece of information won't be delivered to all network participants in a fixed number of gossip iterations. And the second one is network traffic utilization. It shows the size of messages sent by the node for a fixed time interval. One of the factors that affect network protocol efficiency is the consensus protocol. It's a mechanism to solve the Byzantine generals problem, and in this problem, all network participants must agree upon the data state. It is assumed that there are loyal nodes and malicious nodes in the network. In this work, we studied the DBFT consensus protocol, which is used in the neo blockchain. Another factor in the actual model of the network protocol. In this paper, we studied the epidemic algorithm of the neo blockchain, its main phases, and how they affect the bandwidth utilization rate and the speed of information dissemination. These factors were generalized to the case of blockchain networks that use consensus algorithms based on their proof of stake. And as a result, we picked out the most important features of gossip-based protocols in an untrusted environment. First of all, it's high bandwidth utilization of consensus peers. Secondly, it's minimal use of aggregated network information. And finally, it's an ability to select a random node for information exchange. These features affect the whole network efficiency, so they are the ones that need to be optimized. Except for the two metrics described earlier, we also use block level and peer level latency metrics to evaluate the protocol efficiency. Latency at peer level shows how much time peers take to receive blocks starting from the beginning of their dissemination. And latency at the block level shows how fast blocks reach each network peer. The aim of our study is to minimize these metrics. So based on the studied information, we developed 3 ways to optimize the gossip protocol. First of all is introducing fan-out setting. It assumes that the node is able to dynamically tune the number of peers to forward new block to. Secondly, it's randomization of the source gossiper. This way assumes that we set fan-out of the consensus nodes equal to 1. And as a result, the source gossiper is chosen randomly from the number of the consensus node neighbors. And finally, we suggest to use infect upon contagion technique for the push phase of the gossip algorithm. It assumes that each time peer receives the block, it forwards this block to its neighbors until the stop condition is met. We evaluated the efficiency of proposed improvements by simulating the neo blockchain network. Throughout the whole experiment, we measured key metrics of how blocks spread across the network. In each of the experiments, we deployed a network of 101 nodes. 50,000 transactions are sent to the network, and these transactions are collected into blocks by 4 consensus nodes. And then blocks are distributed over the network. We use powerful hardware from the Resource Center of St. Petersburg State University, and each node was launched separately in a Docker container. We implemented a transaction sending mechanism based on the neo-blockchain stress testing tool. We carried out several network simulation experiments. First of them is for the original protocol to be able to evaluate the efficiency of the proposed optimizations. The next three are for each of the proposed improvements separately, and the final one is for a combination of the infect forever model for the push phase and introducing fan-out parameter, because these two are closely related. And here you can see the results. Original evaluation is on the left plot, and the best improvement result is on the right. As you can see, by randomization of the source gossiper, we were able to significantly decrease frame non-delivery probability. We choose 20 seconds as a reference value, so the probability was reduced from 6% down to 2.3%. Also, time of the blocks dissemination was decreased more than twice. Here you can see the results for block level latencies, while the original configuration requires up to 2 seconds, 59% of peers using impact upon contagion protocol increases this value to 82%. Results for latency at the peer level are presented. Source gossiper randomization decreases maximum block dissemination time for all peers in more than 2 times. Finally, the most inspiring results were shown for network bandwidth utilization by randomization of the source gossiper. It's experiment number 2. The traffic usage by consensus peers has been reduced by almost 9 times, and at the same time, the average level of traffic consumption by regular nodes remains almost untouched. And here you can see the results, the summary of all experiments. The best metrics values were achieved using randomization of the source gossiper. That's experiment number 2. And namely, is a decrease in the frame non-delivery probability by more than 2 times, and reduction in network traffic consumption by consensus nodes, while average traffic consumption by regular nodes remains almost the same. The result in this work, we have defined the key features of gossip protocols in an untrusted environment. These features affect the efficiency of information dissemination in blockchain networks. We also have studied target metrics that determine the efficiency of the network protocol in the blockchain. Based on this information, we developed 3 ways to optimize the neo-blockchain network protocol, and significant efficiency improvement in target performance metrics have been achieved. And finally, we have also compared the evaluation results and implemented the most effective one to be a part of the neo-blockchain, neo-network protocol. As a future work, we are going to study dynamic network topology and the ways to optimize it. Also, we are going to generalize the results of our work for the case of blockchain that works on proof of work concept. That's all for now. Thank you for attention. I'll be glad to answer your questions. And Vladimir Korhov is also here.
Okay, thank you very much, Anna. I appreciate very much your presentation of this interesting application of gossip protocols and infection techniques. So I would like to know if anyone of the public has any question. Please go ahead. Okay, if there are no questions, I have a question. The question is about the data set for experiments that you have used. Since you have a probability component, a very strong probability component in your model, I would like to know how do you, which kind of data set you have used, if any, and how do you cope with this aspect to experiment settings where you have a probability? Okay, so this is the experiments that you have done, but my question is this, are these experiments reproducible or what?
Yes.
Just explain me something about that. Okay, thank you.
Thank you for your question. Well, what about the data? The data are transactions, and we measure how our measurements were based on the blocks that contains these transactions. And what is that transaction is in our case? The transaction is a transfer transaction. It transfers one neo as a coin from account to the same account. Basically, the transactions looks like all transactions looks like that, and the results of experiment is completely reproducible with some. They are reproducible. What you hear, what you see in the slides is it's
so
not
parameters of the experiment. So thank you very much, Hannah. And so I declare the conclusion of this second this BDLTA2, and if there are any other question from the public, we will take just one. Okay, thanks. Thank you very much. So I'm glad to open the second part of this workshop that is advanced AI technology for learning technology, AI learning technology. And so this is the third edition of this workshop, which has the very interesting topics and let's say actual current topic on learning technologies and AI, which is a growing area. So I'm glad to introduce the first speaker. If he's here, sorry. So the first speaker is introducing a paper by Pakisho Komshokana and Shute Kujaka, who is talking, who is delivering. Okay, Pakizo, factor influencing infusion and use of online collaboration tool. A case of higher education institution in Lesotho. Please, Pakizo.
Yes, good morning. Can you hear me?
Yes, we can hear you.
Okay,
you
thank you.
Whenever you like.
Okay, thank you for introducing me. And my talk will be on this title that you have alluded to. And my name is Pakiso, and I'm from the University of the Free State in South Africa. And when adopting technology within organizations, it is imperative to investigate factors that may encourage or discourage users from using such technology. And the benefits that organizations get from this initiative is that they are able to identify training needs to focus on encouraging continuance of use. And higher education institutions are not an exception to this practice, because in South Africa, we looked at various universities and then we saw that they are using various learning management systems. So we have the University of Cape Town, it uses Vula, and then we have the University of the Free State, it uses Blackboard, and then we have many other universities in South Africa that are using learning management systems. However, one higher education institution in Lesotho had been lagging behind its counterparts in either using the collaborative environment or learning management systems. And it was only at the beginning of the academic year 2014-2015 that in its lifetime, it acquired the online collaboration tool. And these are the benefits of the online collaboration tool that was introduced in 2014-2015 academic year. And now looking at the infrastructure for the infrastructure that was suggested by the developers of this OCT, they had proposed to use loose coupling, specifically a simple object access protocol. So as you can see, this is the tool, online collaboration tool, and then we have ITS this side. So this is the integrated tertiary software, which is the corporate information system that is used by the institution. However, during the first year of adoption of OCT, the intended integration, as you can see here, that the integration had not been implemented. So this intended integration had not happened. And then the implication of that was for OCT to be updated with data. The OCT team had to be given data on an external storage. And as a result, that caused a lot of inconvenience to the developers of this OCT, as well as the users of this tool. And irrespective of the benefits that we saw that resulted from the use of OCT, statistics indicated that not a lot of intended audience was actually using the tool. And then if you look at the paper, you will see the numbers that we have there as proof that a lot of intended audience was not actually using the tool. As such, based on the unified theory of acceptance and use of technology, the study was aimed to investigate the infusion of the tool and its use by both students and educators at the selected higher education institution. And in this study, we formulated 5 hypotheses, as you can see are listed there. And this is the conceptual framework that we came up with. And then coming to the research design, we used the without model as the research design. And within this design, we followed a quantitative approach. And then we collected data using a questionnaire. And our population was senior students from that selected institution. And our sample was convenient and purposeful, as you can see there. And we used 84 second-year students, 116 third-year students, and then 16 fourth-year students. And the way we collected our data, we administered those 216 questionnaires to our respondents, and our return rate was 72%. And then before the respondents could fill in that questionnaire, we gave them the consent letter for ethical purposes. And the instrument that we used, it had 2 sections, and section A was capturing the demographic details of respondents, and section B had statements about the experiences of respondents with the use of this online collaboration tool. And then we had 23 statements about the use of OCT. And then from the without model, the statements were about the 5 constructs. So performance expectancy, effort expectancy, social influence, facilitating conditions, and behavioral intention. And then these statements were tested on a 4-point Likert scale. And the reason why we used this scale was to maximize reliability by not including a neutral choice for respondents. And then what we did was that we conducted reliability analysis, and this analysis helped us to delete and also to combine some constructs. And then we had the performance expectancy construct, and then the Cronbach's alpha was 0.75, and we had used 3 items. And with effort expectancy, we used 5 items, and then the alpha value was 0.86. But then with social influence, with the social influence construct, we had five items, but then we had to delete 2 items in order to improve the reliability. So the reliability increased from 0.2 to 0.64 when we deleted those 2 items. And even with the facilitating conditions, we had 3 items, but then we had to delete 1 item, and then our reliability increased from 0.47 to 0.62. And with youth behavior, we used 2 items. And now our results. So with our hypothesis 1, the correlation analysis confirmed our hypothesis. And then when all the other variables were controlled, then our hypothesis was as well confirmed. And then the observations that we made from these data is that students were eager to use OCT because they believed they could benefit a lot from its use. And then the digital native students are definitely willing to embrace the new technologies. And now coming to hypothesis 2, correlation analysis confirmed our hypothesis. And even when all the other variables were controlled, then our hypothesis was still confirmed. And then our observation from this data was that of the factors that attracted students to use OCT and kept them using it was the ease of use that was associated with it. Now coming to the third hypothesis, the correlation analysis confirmed our hypothesis, but then when all the other variables were controlled, our hypothesis was not confirmed. And then the observation that we made from this data was that students did not use OCT because they had been influenced by people around them, but it was because they just wanted to use OCT. And now with hypothesis 4, the facilitating conditions, so our hypothesis was confirmed with correlation analysis, but then when all the other variables were controlled, then our hypothesis was not confirmed. And then the observation that we made from that data was that students felt that the environment was conducive for them to really use OCT to achieve their objectives. And on hypothesis 5, correlation analysis confirmed our hypothesis, but then when all the other variables were controlled, then our hypothesis was not confirmed. And then we learned that the behavioral intention of students to use OCT did not have any influence on their actual behavior to use the tool. And in testing hypothesis 5, we followed 3 procedures here. And in the interest of time, I will not go into this. Maybe during Q&A, we can just have a look at how, these procedures that we followed in testing hypothesis 5. And in conclusion, we say technology plays a vital role in the learning of students if used effectively. And all parties that should partake in using the system or technology must do so in order that its benefits will be realized. And this should happen irrespective of your culture, irrespective of your thinking abilities, irrespective of social interactions, and irrespective of the resources that students have at their disposal. And students actually use technology irrespective of whether they think they will learn or not learn from using it. However, we found in the study that students are interested only in some components that each one finds interesting to use. And students completely ignore other system or technology components that they are not interested in. And I would like to thank you for your attention. And now I can take questions, if any. Thank you.
Okay, thank you very much, Keia. How do you say? And I would like to know if anyone of the participants has any question for this paper, for Paquiso. Okay, Paquiso, I would like to know, have you considered, since you are basically experimenting, say, this investigation on the use of online collaborative tools, from what I understand, you have experimented it in your university and in students which are basically in a controlled environment. And I'm wondering if you have considered to include in your analysis, in your report, also some data log, for instance, of practical use. I mean, you have the ability to check what is the use of the technology with respect to what the student declare. Of course, about the motivation, you rely strongly motivation and social factors. So you strongly rely on the questionnaires, of course, but you can also integrate some analysis on the actual use of the technology, because since you are in a, let's say, a controlled environment, you can actually verify what they have used. Have you considered this aspect to be included in your research?
I think that's a very good idea. And then the thing is, I was a little bit distant from the developers of this tool. And as such, I didn't go into the details of having, that data to see as to the activities, the closed activities that students are performed. But then I think it's a good idea that in extending this idea or in extending this paper, then I can look into that so that I can go to the developers of this tool to say, can you share with me the student logs so that we can see how we can analyze that data and then come up with something from that.
Okay, is any other question from the public? Okay, if this is okay, thank you very much, Paquiso.
Thank you.
And I'm glad to introduce the next speaker, which is from University of St. Petersburg, and is Gulmira. I think it's Gulmira Baganova speaking. Is it Gulmira? Yes, I guess. So let me introduce Gulmira, which is from Eurasian National University in Kazakhstan. And the title of the paper she's going to present is The Model of Curriculum Constructor. Please, Gulmira, go ahead. Mm-hmm. We don't hear you, please. Can you speak, say a word just to check If we can hear you. Yes, okay. The mic was off. Please, Gulmira, you're welcome.
Un problema suo.
Yeah. Puoi lasciare questo microfono aperto, ma che gli dico.
Sì, sì, è aperto.
Okay. So we check again. Questo che è, scusa? Ah, ok, perfetto, la videocamera a lato. Anche lo puoi usare anche come per acquisire un libro o un appunto di carta, no?
Sì.
Okay. We still cannot hear you, Gulmira.
So, Gulmira, please check on the Jitsi settings if the correct microphone is selected. Sometimes it can switch to another one. So please ensure the right microphone is selected.
So that the driver of the microphone, I think there is a 3-dot where you can configure which microphone.
Yeah, if you go to the 3 dots and then settings.
Near the mic, the red button, there are 3 dots.
And then settings.
Settings.
And then you can choose the microphone on the second slide.
You can try another microphone. Among the one available here, we have many microphones available. Maybe you have at least 2. And select the right one. Altrimenti andiamo al prossimo speaker. Okay, while Gulmira Bakanova is trying to set up, Gulmira, anytime you can try to speak. We can, if it's ready, we can go to the next speaker. We anticipate the speaker because we have a very tight schedule. And we introduce the next paper, which is from Anton Ankin, Oleg Sichev, and Mikhail Denisov, Inference Engine Performance in Reasoning Task for Intelligent Tutorial System. So I think is Anton Ankin speaking. Yes. So please, Anton, you can connect. Do you hear me? Anton? Or Oleg Sichev, who is speaking? Yes. See who is this? Anton Hennicke. Okay, Anton, you can go ahead whenever you like. We will connect to Gulmira later. Can you try to speak? We can check your mic, Anton. Turn on the microphone, please.
Do you hear me now?
Okay, we can hear you now. Okay. You can go back to slide number 1.
Okay, do you see the slides now?
Excuse me?
Do you see the slides now?
Yeah. We see and hear you clearly.
Okay, let me start. Hello everyone. My topic of my talk today is an inference engine's performance in reasoning tasks for intelligent tutoring systems.
But sorry, Anton, we see your interface of PowerPoint. We don't.
Sorry.
Okay. Now we see the first slide, and then you have. Okay.
Is it
Now
okay
it's
now?
okay. Now it's okay. Okay, you can start,
Okay.
please. Right.
Okay, so the topic of my talk today is inference engines performance and reasoning tasks for intelligent tutoring systems. So logic programming is a well-known paradigm of programming that can simplify the implementation of complex intelligent systems like expert systems by separation of logic from the application itself. But contrary to the common imperative approach in programming, it requires specific software to run to implement this approach. So in our research, we are working on some kind of intelligent tutoring systems that help students in learning programming. Intelligent tutoring systems often require logical reasoning by predefined rules. For instance, solving educational problems can be implemented in this way as well. The reasoning is performed by an application component called software reasoning or reasoning engine. The process of obtaining inference itself can be time and memory consuming, so finding effective software reasoners for different applications is an important research field. In this piece of our research, we performed a comparative study of various software reasoners listed on this slide. CWM or COM, closed word machine, and DLV, an answer set programming solver, performed poorly during the first evaluation steps and were excluded from the following experiments. So the extensive study included 5 software reasoners. It is Pellet 2.3, it is an Untitled web language reasoner supporting several routines. Apache Gina, RDF overlay framework for Java, including rule reasoner. Apache Gina ARQ, a Sparkle query processor capable of running batches of Sparkle update. SweProlog with some web RDF 11 package for handling RDF data alongside Prolog native predicates representing the domain rules. And Cilingo, it is answer set programming tool that combines Gringo Grounder and Clasp solver that handles data as ASP facts. No native support for RDF providing in that case. So reasoning in general follows the schema shown on the slide. The key components include a knowledge base and a rule executor called a reasoner. In this widely used schema, inferred knowledge gets back to the knowledge base, enabling more new facts to be inferred by reasoning engine. We aim to compare reasoners in terms of their suitability for constraints-based intelligent tutoring systems. To do it, we used 3 sets of rules scaling the size of 5 datasets representing inference tasks common for intelligent tutoring systems. Traces domain concerned tracing of execution of small algorithms that can be used to capture how a student understands the execution of loops, selections, and other constructs in structured programming. The expression domain is also related to introductory programming tasks, and this domain deals with concepts of priority and associativity of arithmetics and other operations in popular programming languages like Java or Python. One more domain we used to evaluate the reasoners is discrete event calculus. It is a simple formal model describing changeable objects and events that affect their state over the time. This formal model is useful for tracing state of a stateful object, for example, lifetime of a variable or some class instance in programming, and so on. For this study, we converted 3 selected rule sets representing real-world intelligent tutoring systems problems to the rule syntax of all studied reasoners. For each of the selected reasoning methods, it was necessary to convert the original several rules to the native format since no reasoner other than Pellet from the considered reasoners supports Swirl rules with built-ins. For ASP reasoner, a triple was simulated by a ternary predicate T, while an RDF term was expressed as a string or term literal. This table on the slide summarizes the comparison of rule languages or rule formalisms used by the studied inference engines. The features were explored and selected manually to show the practical capabilities of a particular language that a programmer or an expert has to deal with. Each reasoner was invoked many times as a standalone process during the research, and for each run, the following metrics were recorded: input problem size, the number of input inferred and the output triples, load time, exclusive time, CPU load, and memory consumption. Evaluation results separated the reasoners into two groups. The empirical estimation of a reasoner speed and its CPU and memory load is shown as the colored bars without a strict scale, just to show the difference between each group of reasoners. The measurement results for the traces domain, the first domain of tasks, are shown on this slide. Each plot shows the dependence of the metric on the size of the problem being solved for several reasoners. In our case, the complexity of the solution is reflected by the number of inferred triples facts, which is depicted on the horizontal axis. The top two plots on the slide show that the worst in terms of time is the Pellet reasoner. Prolog is fast on small task sizes, but slows down on large tasks, task sizes. Gina and Sparkle are quite close in time, and Clingo spends a significant share of time on input-output and interpretation of results. Load measurements show that Prolog and Clingo are quite undemanding to compute resources, while Java-based engines consume a lot of memory and use all possible CPU cores on the server. Other datasets show similar results in time, except that Prolog that became faster than Sparkle but remained slower than Gina. In addition, it turned out that Gina can fail with an error due to memory overflow on tasks with a combinatorial explosion. Clingo, by contrast, performs well with a combinatorial explosion tasks. The measurements of memory consumption illustrate the points of memory overflow that Gina reasoner experienced at 2 GB of memory. Prolog and Clingo are still low in memory and CPU consumption. Pellet is the worst in all metrics again on this slide. You can see that. Another type of graphs on this slide is designed to compare reasoners simultaneously in time in memory. Time is on the vertical axis and memory is on the horizontal axis. The polygons indicate the metrics of different reasoners for the same problem size. So the best reasoner should be located in the lower left corner of such a polygon, and divergences on other vertices show a tendency to increase in time as in Prolog or in memory as in Gina on these graphs. So in this study, we compared features of rule definition formalisms for different approaches and measured run and wall time, average CPU load, and peak RAM usage based on the count of inferred RDF triplets facts. The experiments show that Apache Gina infers the solution quicker considered on the most of tasks in intelligent tutoring systems, but consumes a significant amount of memory while C-link performs significantly better for combinatorial problems. Since the time the research was conducted, Apache Gina was integrated as a backend reasoner in the intelligent tutoring system prototype that is developed by our research team. And Gina performs well and should be treated as a state-of-the-art solution for ontology-based expert systems for educational tasks for intelligent tutoring systems. And future work in our research includes diving into the JBoss engine and similar evolution of it. Thank you for your attention. Any questions, please?
Okay. Thank you, Anton, for your nice presentation. I think your work is very significant because it can give direction. You know, so detailed comparison of performance on different reasoning system for supporting intelligent tutoring. So my question is. How significant is the domain that you have considered? I mean, you have to encode the same problem in different aspect, or in different framework, or did you actually use different okay, the data set traces 520 lines. Okay, I see in this slide some part of the answer. So my question is basically, how did you make it possible to re-encode the same kind of rules in different framework? Or can you explain something about that?
Yes, we have used data sets for 3 different tasks that are common for programming education in intelligent tutoring systems, and converted all the rules we have used in these tasks and that are used in different frameworks. We have converted it from severe language to native format for every reasoner. We have tested to obtain the results from different reasoners on the same tasks.
Okay, so basically you consider the same task a short task, of course, because you have to encode again in YIN, ASP, and some other framework. And so I think these tasks could be interesting to, you know, to spread and diffuse among the community, so they can actually compare with the same examples. And are these tasks, particularly used in your university, no? For teaching?
Yes, some of tasks are used in our university, and you can see on these 3 slides the links to research that are dedicated to these tasks as well.
Okay. Any other question for the public? Okay, thank you very much, Anton. We can proceed with Gulmira. If Gulmira is ready, can we try again the connection, Gulmira? I see you a few seconds ago now, you disappear. Yeah, hi, we see you. Welcome, Gulmira, again. Very glad to see you unfortunately online. We would prefer to see you in person, but we cannot hear you. The microphone issue is still there.
And now?
Yeah, perfect.
Thank you. I just changed the browser. I think the problem was with the browser.
Browser.
Thank you. I'm sorry for this technical issue.
Never mind. You can imagine in the whole conference how many problems of connection arise. But I know it's annoying for you, but you finally can go ahead and please. So I don't present you again, Gulmira from University Eurasian University with Atsam Nazirova, Asela Barnikova, and Martin Karibai. The model of curriculum structure, you can start.
Can you hear my screen?
Приятно увидеть родные лица.
Sorry.
Just
a minute. Can you hear the screen?
Yeah, we can hear you and we see the slides correctly.
Okay, thank you. The model of curriculum constructor, I just want to explain what is the background of this work. Nowadays, we are working on e-learning system in our university. My current position is Director of Digital Development Department, and we have a learning management system. And when I started work with this system, I understood that we have a lot of problem with the model of curriculum constructor. Of course, we have the curriculum constructor already in our university, but we have some, as I think, some mistakes in the model. And when we start to work in new model, we decided to use some artificial intelligence methods for this construction. So I tried to explain. The main issue of this research is create an estimation model of achievement of curriculum goals. I can say that the Kazakhstan wasn't in Bologna process till 2010, and we had another way for curriculum construction that it usually needs for Bologna process. And when we started to work in this new system, we received some problem like that our professors and staff, they continue to use our old model, which not related for education program goals and learning outcomes. It was design of curriculums was curriculums consists of goals, outcomes, and competencies, but in the system we cannot have possibility to check is this goal and competencies are achieved by students. So we decided to create the new construction in our university, which should check the goal, that the goal of educational program is achieved, learning outcomes and competencies are achieved by students. So curriculum design consists of several stages. I think that in every university you have some similar model. The education program goal achieved is carried out through the educational program learning outcomes. Each learning outcomes is associated with one or more expertise, while the expertise are associated with set of disciplines, and to achieve the curriculum goal in the context of program disciplines is ensured by the student's competency mastery. So in our construction, we have users in our system like internal experts, external experts, administration staff, and academic committee members. Here you can see the process, how every users in this system works, and what is the algorithm of this Okay, now you can see the schema of information system, so which necessary for creating curriculum. So here I just try to explain in short. The academic committee members develop the curriculum, enter general data, goal, type, degree, and so on. And the academic members develop the discipline catalog. Administration staff develops a template for the curriculum sets. Compulsory disciplines. Fourth step, the academic committee members will choose the disciplines and complete the curriculum after the curriculum template is developed by staff. Staff checks the finished curriculum is everything. If everything is okay, is correct, staff will be sent it for expertise. Or if curriculum has mistakes, they can send curriculum back for modification or revision. There is a roster of experts. The staff appoints experts for a specific curriculum. The experts review the curriculum, and the expertise is carried out in accordance with the certain template. So if the curriculum is correct, it will be sent by approval. Otherwise, it is sent for further modification. The staff downloads the curriculum, prints, and gets the scientific board approval. So it's just the explanation how we do this work in our university, but the main goal of this work, create the model where we can check that we have relations between curriculum goals, learning outcomes, competencies, and disciplines in the whole using the ontological model. So, just a moment, sorry. We create some sets of competencies, set of outcomes, which corresponds to each other and corresponds to goal of the program. How it shows on the slide in the formula. Here you see the mandatory learning outcomes, which represented as a set 2. And the example of a curriculum ontological model you see here. So we use, as I said, a lot of sets, and every discipline is corresponds to competencies to outcomes, and outcomes to goal. And then when we create the curriculum, we can check that we have all of competencies are included into the curriculum, and all disciplines corresponds to these competencies. And even after the students finished to study by this curriculum, we can estimate if has he achieved the goal of program, not only number of credits, but all competencies which necessary for this educational program. This is the main idea of this paper, and this is only part of our work because we have the module which estimate knowledge of students by extracting the knowledge, and we have the module which estimate the progress of the students when he studied in disciplines. And no, I think that maybe later we can prepare some extended paper which explain all part of this work, because this work consists of several parts, which will work, I hope, like a system next year, because nowadays we realized 2 parts from these 3 parts of this system. So it's in short. If you have any questions, I will be happy to answer. Thank you. Can you hear me?
Yes. Hello, Gulmira.
Hello.
It's Valentina here.
Oh, Valentina, nice to hear you.
I have a question for you. So this formula that you used for the competencies, for the learning outcomes, in
Yes.
your opinion, maybe used also for skills for particular jobs, for example. So if there is a particular set of skills required for a job, do you think it can be applied maybe with some editing?
Thank you for your question. If I understood well, I think that it's possible to use for every, not only for, I mean, the curriculum for the students. It could be this model could be used in every study process where we need to estimate if the skills or competences or knowledge results or learning outcomes will be achieved. So this is just like verification if we achieve the results and achieve the goal. Because nowadays we don't have any estimation. We have some marks of students, but we cannot say if the students achieve the goal of the program. Maybe they just have a lot of different models which don't correspond for the goal of their program, which we'll choose first.
Mm-hmm. I mean. Okay, so with a set of titles, let's say, instead of the learning titles, maybe applied, because I know that there is a high request for algorithm to be applied to expertise selection. So it may be future work.
Thank you.
Thank you.
Okay, another quick question is about using your algorithm for maintenance of different curriculum. Maintenance in the sense that the curriculum also changes dynamically, and yes. I think you can see the impact if on the curriculum if the university changed the programs. Because very often the program change over the time and they're not very stable. Let's say new topics are introduced and so on. So is your system able to adapt?
Okay, I can explain. We have some mandatory learning outcomes and some elective learning outcomes. For that means if these learning outcomes is mandatory, we cannot change them because they're necessary to be achieved. But some set of outcomes, they're elective or variable, so they can be different every time. The student can change them according to their choice or according to some differences in market, in labor market. And we have some restrictions according to the credits. Some of the ICCS should be chosen from mandatory models. It's necessary, it should be some amount of ECTS. And some ECTS should be changed in the wish of the students every year. And of course, for future work, it could be better. I think that it should be very good if we can change this model. The set of mandatory models, if it should be flexible, not only for 1 year. But nowadays, only maybe expert can change something in the mandatory model because our system couldn't do it at the moment.
Okay, thank you, Gulmira. We are then to conclude this session, and I hope that the public were interested and stimulated by the nice ideas that you have presented. And of course, I invite you to submit next year. And as a news, I will send an invitation to the best papers of this of this workshop to submit for a special issue of journal. Okay. So
Okay,
please,
thank you. Nice to see you at
nice
the.
to see you. Thank you, Anton. Thank you, Gulmira, and thank you to the other participants. Thank you to Paquizo. So thank you,
Thank you.
and bye. Bye. Okay.
Is on.
Good morning, everybody, and welcome to the 15th slot of the session General Track 6, which was introduced this year to collect papers around the general theme of planning. And the sixth and last slot will follow at 11:30 and will be chaired by Chiara Garau. 4 presentations are scheduled in this session. We have 2 presenters in the room, and I hope the other 2 are already connected. Just a couple of general remarks and directions. So whoever is attending on Jitsi, please mute your microphone where you are not speaking. Presentation should take around 10 minutes, so we can have 5 minutes left for discussion, comments, questions, whatever. And I will signal when you're about 9 minutes, so when 1 minute is left. So whoever has any comments, please just wait until the presenter has ended, and we will collect your questions. So the first presentation is delivered by Maralado, and it's a work, Mara, here please. And it's by Ginevra Balletto, Giuseppe Boruso, Alessandra Agnesi, Maralado, Paolo Castiglia, and Marco Vettori. And the title is For City Planning, a proposal for an index to support decision-making practice, principles and strategies. So Mara, the floor is yours.
Thank you. Okay. Good morning. Hello, everybody. So, as Sabrina said, everyone, this paper has been written by Balletto, Boruso, Milesi, me, Castiglia, Dettori, Arditu, as for city planning, a proposal for an index to support decision-making practices, principles, and strategies. So, some important issues guided our study. First of all, cities were among the more affected areas hit by the epidemic, and many scenarios have been advanced for a renewed urban development to support the reduction. Sorry. And many scenarios have been advanced for a renewed urban development to favor the reduction of contacts, including the idea of the 50-minute city. Some questions guided the present study. What are the multi-sectoral policies that can make cities more sustainable, reducing vulnerability and health risk? What individual commitment can city make into a model of health promotion? So, to answer these questions, it was necessary to retrace a background of health aspect and the urban geographic aspect. Regular physical activities is one of the major lever factors in health prevention. Despite the well-known benefits for health, the high percentage of people physically inactive is a growing global concern. In Italy, the habit of physical activity is not the same in all regions. For example, in the Sardinia region, it is estimated that 26% of the population can be considered completely sedentary. According to the BES report 2020, we can see that the level of overweight people in the northern and the southern Italy grow in the year 2019 and 2020, and in the southern Italy is higher than in the north. Starting from this consideration, this is the reason why today the application of crossing sectoral strategies is needed to enhance the physical activity level. There is growing scientific evidence that the urban design features at the neighborhood level, such as green spaces, parks, pedestrian areas, which favor walking and cycling and physical activity in general, are associated with beneficial health impact on the population. We also should consider that in Italy, more than 4 out of 10 people practice physical activity in a completely unstructured way, preferring open spaces and not always equipped. So in line with this consideration, the study aims to define an index to guide urban planning and future urban design policies to improve the degree of the so-called sportiness of the urban environment, especially in favor of all those physical activities included in the category of unstructured sport. The attention has been on analyzing the performances of Sardinian provinces and the metropolitan city of Cagliari in the terms of the parameters that are more likely to positively affect human health from the planning point of view. So we set up a comparison between the data relating to structured and unstructured sporting activity in the Sardinia provinces and in the metropolitan city of Cagliari for the 3-year period 2018, 2019, and 2020. In this study, we mean structured activity as those activities related to sport federations managed by a specific subject. It is represented by the sportsmanship index proposed by Il Sole 24 Ore. At the other end, unstructured activities refers to all those activities carried out outdoors, individually or collectively, in a self-managed manner. The unstructured sporting activity required a specific elaboration proposed by the authors based on the quantitative evaluation of pedestrian areas, cycle paths, and parks linked to urban design. So the research proposes an Urban Physical Activity Index, UPA, to support sport city planning initiatives, able to improve the quality of life and health through urban design. The index involves two aspects. The first are the 3 urban design components that we recognize in the pedestrian areas, bicycle lines, and urban green areas. The second component is the incidence factor, respectively, for the 3 urban design component on the efficient use of land, which is the synthetic index that we consider in this elaboration. So the UPA index was applied to the Sardinia case study for each province for the 3-year period 2018, 19, and 2020. The incidence factors of the urban design component were determined empirically from the evaluation of the urban and territorial context. So we can say that the incidence factor is measured in the urban green areas more than in the pedestrian areas. Cagliari and South Sardinia present the most important values in terms of unstructured endowment. At the other end, the province of Sassari hold the lower value. The city of Cagliari witnessed the major result from the action performed by the local authority for the 2017 European Capital of Sport, as certified by the European Union. So, in conclusion, the proposed index combines existing sport activities and practices, particularly at urban level, both related to structured and unstructured solutions, also considering the relation they can have with city planning. If we consider that usual and typical indexes and indicators focus on the structured supply of sport clubs and facilities for classifying city and evaluating their performances as health and sport-oriented one, the UPA index can be considered a novel approach which recognizes a new character for planning the city of the future. Thank you.
Thank you, Mara. Thank you for your interesting presentation, but also for your time saving.
Okay. Thank you.
Does anybody have any questions, either online or from the room, or comments or suggestions to Mara? Okay, I have,
Yes.
I don't know if it's a question or a comment, but it's related to the unstructured part of the index. I was wondering whether measuring the size of parks, the length of paths would be appropriate, because it's a rough estimation. There's people running every place in Cagliari, for instance, so the two things might be not properly correlated. Would it be possible, for instance, to deliver questionnaires or something like that to gather more insightful data? The data you have for Sassari, for instance, it's really striking in comparison to Cagliari.
Yes, I mean, I think that this is only this urban design component that we recognize are only the first component that we consider. But in the future, we can also think to elaborate a questionnaire for the population and understand what kind of space are needed to practice the unstructured sport activity. So this is only the first step. In the future, we can understand the more complex dynamic of this new scenario that we can see in our cities. So the questionnaire is a best solution, I think, to improve our research activity.
Thank you very much, Mara. And now I would like to ask if Mulalo Yadani is connected on Jitsi. If you are, please unmute yourself. Is Mulalo here? I don't think so. So we can go ahead to the next presenter. Francis.
No, he's here. Thank you.
Oh, okay, apologies.
my mic was off when I was saying yes. So
we
sorry for that.
See you. Maybe you covered your camera?
Yes. I'm going to try and see how. I don't know why is it.
It's like there's something stuck over your camera, so it's almost completely black. Now it's almost everything is black.
Okay.
Okay, nice to see you, Mulalo.
Correct.
So your presentation is about a decision support system for tuberculosis prevalence in South Africa. You're welcome to share your screen and start your presentation.
Okay.
Yeah.
Thank you very much.
So
I'm going to
10 minutes for presentation, please.
I'm going to share my screen and you manage select speaker settings. Where do I share my screen now?
Is everything okay, Mulalo? Can we have?
Yeah, I'm trying to share my screen, and the options I'm getting here is where I'm still. Okay, I got it now. Share your screen. Thank you. So I don't know whether you can see it.
Yeah, we can, but we are on testing and results.
Yes, so I'll be very quick. So this is about this work which we did, and this is about tuberculosis. This is a disease that is really affecting South Africa and more so even other countries that are in the same income bracket with South Africa and even some below. So a decision support system for tuberculosis prevalence in South Africa was done here, and we took a case study of one province, which of course we collected data and managed to do quite a lot with it and show the state of the affairs in the country in terms of this particular disease. So the presenter is Paul Kogeda. Mulalo is not there, so I'll be the one presenting it. So tuberculosis is an airborne kind of disease that is caused by a bacterium that mostly will affect your lungs or the lungs, but there are also other areas it can affect, like we talk of bone tuberculosis, among others, which are also there and well known. And in South Africa, as I've said, is one of the most, or the countries that is actually mostly affected by this particular disease. There are so many studies that have also been taken to find out why is this so, of which you find most of the issues or reasons people give include the HIV AIDS kind of burden, and the poverty, among others, are some of the reasons that bring in or make sure or cause this particular disease to be of a burden. So you find that in 2013, there was around 320,000 infections. That is just the TB. And in most cases, you find there is kind of like more than some kind of 20 or so percentage of people that end up dying. And if you talk of the latest statistics that we have, because this study was done sometimes back, but there are latest statistics as we are still continuing to study and monitor and even to help the government in preventing some of these diseases. And at the moment, if I may just say that in a second, we have integrated the coronavirus into the whole bunch of diseases that actually go hand in hand and cause a lot of mortality. So the latest statistics is 450,000 people were infected the year before, which is really quite a number of people. And out of that, you'll find around 30 or so thousand people get or die. And the people that die are actually people in their prime and productive age of they are employed, they are parenting and all that. And therefore, when these things happen, when these people die, we lose skilled people, and we also lose in terms of income. We also lose in terms of productivity, of which affects the economy. And in the sense also, once the breadwinner is dead, then there comes the issue of who will take care of the people that he was taking care of. In most cases, he's taking care of his parents and also his kids. And therefore, all these, they go to the what? They go to the state, of which the state coffers are also affected as a result of this kind of deaths. So therefore, the disease impacts the economy, the family structure where kids grow without their parents, and this actually slow down the growth of economy as the government spends also a lot of money in terms of budget and social welfare to cater for these people that have been left orphaned. Discourage investors, thereby affecting business and government revenues, because if investors come and you are told that there is kind of high burden of disease, which basically might eliminate 2 or 10 of your employees, and you'll be faced with a situation to look for newer employees and train them and spend a lot of money on them, and then they also die again. So it can discourage investors, which of course we know the ripple effect. Therefore, this necessitated us to actually create a decision support system that is based on Bayesian network as a tool and to help curb this epidemic so that we can help the government to mitigate this disease. There are people that have done a lot of work in this particular area, of which some of which I'll mention here. We have Kumari, Rajan, and Anshun, which did the prediction of diabetes using Bayesian network, of which diabetes is a very also another disease that is affecting quite a number. In fact, it has now overtaken the tuberculosis in South Africa as the worst disease that is affecting most people. And we have we are also working in that, of which we have some kind of a patent that is already done, which we will release and give to the public for later consumption. So Takar and et al., they also did a healthcare decision support system for swine flu prediction using naive Bayes classifier, which of course is just a group of the kind of the algorithm that we are also using. Palaniapa and Rafia also did some kind of intelligent heart disease prediction system that was using data mining techniques, where they used neural networks and all those kind of data mining techniques in order to do this particular work, which also somehow similar to what we are also trying to do. However, they used some others which we did not use in terms of algorithm. We have Sarah and Niaka and Xiaojun, who evaluated and compared different machine learning methods to predict outcome of TB treatment course, which of course it's speaking towards what we also did here in the sense of or trying to predict the TB and how someone can actually contract the TB given certain information that we may have at hand. Now, these guys, they just did the treatment course to find out, as per the person who is going to, or who is on treatment, who has contracted the TB, will he actually be healed or he might not get healed? Of which that is also another problem, that we have high mortality rate in the when once people contract the TB as a result of not following the treatment that is put forward there. So,
Mulalo, 3 minutes left. Could you please?
Pardon?
3 minutes left. Could you please go to the most important part of your presentation, methods and results?
Okay, 3 minutes. I've not even taken 5 minutes. Okay.
No.
All right. So we have others like Kogeda, Apinya, and Omlin who did probabilistic approach, and we have Utu, we have also Hota who did prediction model for mitigating TB prediction. But he was taking this in relation to HIV patients, as I've mentioned previously, that this is also why we have high mortality rate as a result of most people who contract TB are actually HIV positive. So Bayesian network was one of the algorithms that we used here. Actually, is the algorithm that we used here to perform this, and Bayesian network is well-known kind of an algorithm that was developed by Thomas Bayes, and it has been used widely in various areas, and this is one of the areas that we actually try to apply it. So probably we kind of looked at a joint probability distribution, where we can actually see that whatever data and the information that we have, we can actually be able to find and get to the root cause and how the person will react. So we have this conditional probability where we talk about the prior probability of an event A without any information about the event B, and then we have this PAB is the conditional probability of the event A given the event B, among others, as some of the data that the algorithm that we used, and this equation actually help us to do and mine the data that we had. So, but why did we use Bayesian network? They are graphical models and can be represented relationships very clearly and easily. They can also clearly depict the direction, thereby showing cause effect, which of course is what we need to understand whenever we are dealing with TB to prevent and also to mitigate this effect. They are able to handle uncertainty, and they also handle uncertainty using the theory of probability. So in designing our system, we try to come up with a top level kind of use case, of which you see here someone who is looking for probability and maybe wants to go somewhere and want to find out how this particular area is, and can actually instruct that information, which of course the data will be entered by the health practitioner, who enters that information into the database that is again going to be mined, and we are liable to get the latest real-time kind of, near real-time kind of information about the status. So this architecture can show you here where the database is, and here is where the Bayesian network works, and information is processed, and then you can have, as a user, you can have your mobile phone and you'll be able to extract that information and get to know, so that you don't just go any other places as a result of whatever you have, because you want to actually prevent the being infected. So the sample data of patient data set is looking like this, where we can have this kind of information showing you the locations and all that information. The definition of possible states, we did this, which of course is the data that we had, and using this equation 3, we can we implemented or computed the probability using that equation, and when you see the answer that we got here is 0.05749, which of course is telling you what kind of possibility you can get whenever you have or face this kind of a situation. So you'll see some of the tests and results that we found, which of course you can see the main TB, which was affecting many people, is actually pulmonary. And we also had extra pulmonary in this particular area or location that we got data from. and these are the locations, and you can see the way they share the data. And you can see here the male and versus female. So you see the male are also carrying more burden of the disease, just like it is with the coronavirus. Then you can see here with the type of age groups, and you'll see that we have the age group 0 to 35 is more affected, followed by 35 to 65. So you can see again here alive and dead, so how many people will survive, and you can see here that actually 13% died and 87% actually recovered from the TB. So the probability distribution is shown in this, of which you'll see when you look at these figures, actually will show you which actually is more vulnerable. So the results show of 5 tests, of which you can see here how we predicted the outcome and what actually came out. And when you look at the utility, this is what it shows. So thank you very much. This we conclude by saying that we made around 63 runs, though we could make more and also do more, of which we have done this with other researchers in other work, which of course some of which have mentioned there as related work. And we got utility of 88, which of course can also still be improved upon. And Bayesian actually served well and used in this research was very much handy in terms of doing the work that we wanted it to do. But yes, in future, there could be a test of other, say, algorithms, and also to look at other aspects in terms of performance of the very system that we did. Thank you very much.
Thank you very much, Mulalo. Thank you also for the effort of condensating all of these in only a few minutes. Does anyone have any comments or questions for Mulalo? I have a very quick question, which I hope will lead to a very fast answer. And it is about your very last slide. So how could these models and the results of your model help practitioners, say health organizations or civil protection agency in their efforts? How can be they useful in practice?
Yes, we have liaised with the health department of South Africa, firstly with the Mpumalanga province, which is a semi-autonomous kind of a region. And we have installed this, which is very important for them to use in order to be able to track down the areas that are heavily burdened with the tuberculosis infection, so that they can take some kind of action and direct resources towards such areas. So yes, practitioners are taking heed of this kind of research that we are doing, and that is one of the ways in which they have actually heeded this.
Thank you very much, Mulalo. Could you please unshare your screen?
Thank you.
So we can move on to the next presentation. Please unshare. Thank you. And I give the floor to Franciszek Kolowski, which is the co-author of the paper on original destination metrics estimation using Bosch-based algorithms, together with his colleague Ivana Kolingerova. Please, Franciszek, the screen is yours. Control L.
Yes, nice, thank you. Hello everyone. I am Franciszek Kolowski from University of West Bohemia, and in the next 10 minutes, I will say something about the origin destination metrics estimation using Bosch-based user equilibrium algorithm. So first, I will make a quick introduction to the transportation modeling. First, you can see some city where we can want to model the traffic flow. The streets are represented as a direct graph, as you can see in the picture. And after that, the city is divided into the zones, where the main property of the zone is the number of trips that originating or finish in zones. And the zones can be also represented by the points that are connected to the networks. So in this case, and after that, it's necessary to compute the origin destination matrix. So the origin destination matrix contains number of trips between each pair of the zone. So initially, this origin destination matrix is computed using some social economic data and the gravity model. After that, the next step is the traffic assignment. You want to assign the origin destination matrix to the network. The first task is to find the paths that are used by the drivers to get from one zone to second zone. Also, you can see that there can be more paths between one pair of zones. So you create the paths, and after that, you simply assign the trips to this path. And here you can see some example. This is like the white of the lines like represents the number of vehicles per hour in the peak hour in the city. So after that, you can have some detectors or some measured values of the traffic flows. For example, coming from some traffic camera or some induced cycles in traffic lights. So, and this measured values of the traffic flows can be used for the calibration of the origin destination matrix. So, more formally, this problem is formulated as the minimalization problem of some objective function. We want to minimize the origin destination matrix G, and we want to minimize the distance between the initial origin destination matrix and the calibrated matrix, and between the measured values and the modeled values. So in our case, we simplify this expression and we use only the second function. And now this problem is reduced to classical least square problem. We want to minimize the square between the measured and the modeled values. So the common method is to use the gradient descent with a long step to minimize this objective function. So the crucial part of the whole algorithm is to compute the search direction. It means like in this case it's gradient. Yeah, and the gradient depends on this difference between the measured and modeled values, and on the probability that the user crosses the edge A on the trips between the origin I and destination J. And the aim of this paper is compute these values as fast as possible. So there is problem. Problem is that the assignment function, the function that assigns the origin destination matrix to the network, is not available in a closed form. And why? This is why we assume that the drivers, the users, choose the fastest path, and the cost of the edge in the network, the cost of the edge like means the travel time, is dependent on the traffic flow. So is the circle. So now the user equilibrium must be computed. It's the classical Nash equilibrium based on game theory. So this equilibrium can be formulated as a variation inequality problem, this formulation you can see in equation 5. So there exists like 3 groups of algorithms that can solve this assignment problem. The first group is link-based algorithms that solve the problem in the edge space. It means that you get the traffic flow for every edge in the network. These algorithms provide a unique solution, but have a very poor convergence rate, so these algorithms are not suitable for our case. The common approach is to use the path-based algorithm that are much faster, but needs a lot of memory for path enumeration. And the big advantage is that from result of this path-based algorithm, you can directly compute these key probabilities that we want to get. And the third group of the algorithms are the Bash-based algorithms that are the fastest, are blazing fast, and do not need to enumerate the paths, so are also memory efficient. Yeah, and these algorithms are based on decomposition of the problem to acyclic subgraph called Bashes. So, our challenge is to use the Bash-based algorithm for computing the PAIJ values, because the Bash algorithms are the fastest one. So now I show you what is the Bash. Bash is a cyclic subgraph originating at the origin zone and contains all the flows originating in this zone A. Here in the picture, you can see some example of the Bashes that origins at the zone I. And for example, here there is some destination zone J. And here this edges leads to some other destinations. Yeah, and big advantage of these Bashes are that are acyclic. So all of the algorithms are fast on this network because you need only, for example, topological sorting for shortest path search. And this is the reason why the Bash algorithms are so fast. So our proposed method is consists from 2 steps. First step, the aim of the first step is to make the hyperpath from the Bash. It's this. You can see it in this feature. The aim of the first step is to delete these edges that leads to another destination, and then we get the hyperpath. And the second step has the aim determine the probabilities PAIJ using the modification of BFE's algorithm for the destination zone. And then we determine these numbers here are the probabilities. So, yeah, results. We use the algorithm for the traffic assignment, and then we use the entropy maximalization algorithm to determine the entropy maximum result. And we had 2 models. The Pilsen is the city in Czech Republic, and the Pilsen in high congest case. And you can see here that the update runtime of the origin destination matrix is about 50% faster compared to the explicit path enumeration using the path-based algorithms. So the conclusion is that our proposed method of the calibration of the origin destination matrix saves more than 50% of the time that is needed for origination destination matrix updates, and The algorithms also save a lot of memory because the algorithms do not need to enumerate the paths, and the number of paths can in the network can be a very huge number. So thank you for your attention. Some questions?
Thank you very much. Any questions from the live audience? Or from the Jitsi audience? Okay, I do have a question though. Your algorithm was aiming at improving the speed, make the calculation faster.
Yeah.
But my question would be, how do the results compare to the lengthier calculation with the traditional methods? I mean, how reliable are the results in comparison to them?
The results are exactly same. Yeah, so like the results are the same, but we only improve the speed. So now we are like 50% faster, but this like speed up also depends on some other like properties of the network and level of congestion and so on.
So if the results are reliable as much as the traditional one, then one would always switch off to your method.
Yeah, maybe.
But, I mean, somebody like me, I am a planner. I am somehow versed in technologies, but what would I require to use this one? Because it's faster, it's reliable, so I would like to use it.
Yeah.
But could I be able to, or do I require any, I don't know how, Savvy Tech program or something like that?
Yeah, it's very like you must be a good like programmer to implement it, and the implementation takes like 20,000 line of code, so it's a very difficult implementation.
Okay.
That takes me like 2 years.
Okay, so I will need somebody like you to run.
Exactly.
Thank you very much again.
Yeah.
And now we are sort of on time for the next and last presentation of the session. If any of the presenters is here, Mariana Magalhães, Rui Duarte.
Yeah, I'm here. Hello, good morning.
Katia Oliveira and Filipe Pinto, and the title of the presentation is The Role of the Smart Citizen in Smart Cities. So Rui, the floor is yours, and I will give you a warning when you're about 9 minutes.
Okay, thank you. Can you see the presentation?
Yeah, we can.
Okay, great. So good morning to you all in the room or online. My name is Rui Duarte, and I'm here to present the work of Mariana. She's a PhD student working with us at the Research Center in Digital Services in the Human Factors group. Agenda is a typical agenda where first we define our motivation for the work, the state of the art, and then the approach that we took in the analysis. And then we discuss results. We provide some conclusions and future work that can be done with this work in the paper. So the motivation is that regarding cities, we have cities that are smart cities now. However, we feel and we know that citizens are not engaged with the cities. To bring this to a real context, we need to create this relation between cities and citizens and provide citizens the means that they need to engage with smart cities. So we did some survey in the state of the art, and we found several fields. One of them is related to the smart cities itself. So according to Palliser, cities have several problems that they have to deal with, like urban population increase, negative impact on city management, and lack of natural results. And moreover, they can take advantage of technology. So again, according to Kumar and Dahira, we have several areas that the city and where the technology can be applied and be used in the context of smart cities. Another field that we we studied is how participative are citizens. And one of the things that we found out, the relation of citizens with the city has been neglected, either in the literature, because it's focused a lot on the technology, and therefore citizens are not being well studied in the literature according to the smart city concept. So some cities also took advantage of technology to develop some services and applications for the cities, but they are kind of standalone services that just focus on one of the verticals that the city possesses. Another area are participation systems, where the citizen can participate in the city in several fields, in several areas of the city, due to web platforms most of the time. But once again, they are standalone interfaces and software that have been developed. So we defined our approach to set some goals, 2 goals and 3 research questions or research hypotheses. The first goal is to understand how the digital mean can be used to improve the user experience with the city, and define a digital model to enhance the experience in a city, either where someone lives, works, or visits. To achieve these goals, we identified 3 research hypotheses. Understand if the way the city communicates with the citizen influences its participation in the city, if a mobile application is in fact an adequate digital mean for the citizen participation, and if the information that the citizen wants depends on characteristics related to him, like age, gender, and other. Okay, to this approach, we did some benchmarking, and according to Volniak et al., every city has to follow the ISO 37120. That's focused on a lot of area that the city needs to cover and needs to have. Moreover, the areas of smart city have to converge, either the norm and the areas, to the citizens' interests that are defined in 6 levels that should focus on the citizens' interests. And this is where we work at the citizen level. So we carried out a survey, and we defined a set of support questions that we wanted to answer, general support questions, and then we defined our 4 main components to approach the solution and the results that were to be obtained. So we characterized some questions related to sample characterization, relation with technology of citizens, concerns about environment, because the environment is now a key question in city management, and other general questions related and to understand the relation of citizen and the city. Our results at the sample characterization were that 55% were female, and the age average is 31 years old, and most live in urban areas and with other people. Some relevant professions that were identified, and moreover, of the respondents, 73% use personal transport. They don't share that transport, and this is a key factor. About the city and the relevant information for the citizen, either at the city level, we identified 6 topics of interest that the city should provide the citizen, like pollution level of the city, problematic locations, if there are construction sites where they need not to go to, services that are provided by the city, outdoor activities, and public transport. At the citizen level, their interest is focused on 5 topics. They want to receive rewards, they want to be notified about something that happens in the city, they want to have information about entertainment, they want to have information about news, and they want to have info on online products. Another question was about which means of communication that we have in cities influence the citizen to better participate in the city. So social media was found to be one of the most influent means of communication that the city should consider to influence the citizen participation. Next, television, where with information on news and on TV, computer, and so on, web pages, mobile applications, and so on and so on. So the focus here is how can we use the means of communication to influence the citizen to better participate in the city and to provide him information about what's happening in the city. Another question was if they are aware of the use of the technology in cities where they live. And most respondents refer that they don't have knowledge if technology is being used in the city where they live and work or in other cities whatsoever. To validate research hypotheses, we carried out several statistical tests like ANOVA and chi-square tests, if you want to compare different values. And to validate one of the first research hypotheses, if the way that city communicates with the citizen influences its participation, this is a partially accepted hypothesis. In fact, the citizen is interested in participation and provide an opinion about the city. The problem is that it doesn't have awareness if the city has technology or not. So communication from the city may or may not influence the citizen. Nevertheless, he wants to have information about the city. The next research hypothesis is if a mobile application is an adequate digital mean for the citizen participation. And this is an important issue because what we crossed was some of the variables that how can we have the best digital mean, and in fact a mobile application is a good digital mean, but also we try to understand how can the other means of communication influence the citizen to participate in the city. And once again, publication and advertising about the digital means and the way the citizen can participate through different means of communication is a key factor for the citizen to get better engaged in the city. Another question was about the information that the city wants, if it depends on his characteristics as an individual. And we found out that different age ranges have different interests in the city participation and in different topics of the city. So at this level, at the age level, we found out that in fact there is a difference and a requirement that provide the different citizens, different interactions with the city. They want different things from the city. At the gender level, also, we found no many differences between females and males, and at the rural and urban level, also in the services that the citizens want, no differences were also identified. So, from this, we provide.
1 minute left.
Thank you. We provide a recommendation. First, all the companies must work together to get better interchange of, for example, cross discounts for the citizen, and this has to be promoted by municipalities to provide different services for the citizens. Moreover, and this is out of the scope of the paper itself, the student already did this part. We develop a mobile application focused on the interests of the citizen, where it is fully adapted because it's focused on his personal interests, and then he chooses what he wants to see from the city. We think of making it available worldwide because a citizen from one country can and should spend the points that he earns in different cities around the world. Moreover, we give activities for them to earn points. And a conclusion, we provide the recommendation for stakeholders because they have to work together to provide different services for the user. For the citizen. If they don't do that, the engagement and the use of development of mobile applications is not an important factor. And moreover, citizens need to feel integrated part of the city. So if a mobile application is focused on their needs, what they want, then we have a differentiating factor. Future work, we will use business intelligence for city profiles to understand better the interests of citizens, and recommendation systems to generate rewards according to their interactions with the city and the application. Thank you for listening. Any questions?
Many thanks, Rui. Any questions from the room? No? Any questions from the live audience? No? Could you please reshare your presentation? I have a question. I'm not very clear on the first of the three hypotheses. You mentioned that it was only partially accepted, and I was wondering whether This would require further investigation, or in what ways does the fact that it's only partially accepted affect your recommendations?
Okay, I don't know if you seeing the presentation. Yeah. Yeah, this one. Okay. Okay, so the results from the ANOVA were unspecific in certain aspects. So that's why we did not accept this hypothesis. Why? Because the citizen doesn't have awareness of how the city communicates with him. Because he really doesn't know if there are new services that are being provided by the city for the citizen. So the way that the city communicates, if it influences the participation in the city, the answer is and the results are not correct, because we cannot say that the city communicates with citizens. So if it doesn't communicate with citizens at the smart city level, we have no awareness if it influences the participation of the citizen.
But do you need, I don't know, further and larger data to retest again these hypotheses? Or is this enough to ground some recommendation maybe to the city to improve the way they communicate?
Yes, it is, because citizens. We also did some interviews with about 50 citizens, and the response was that we have no awareness. If there are new services that we can use, like IoT parking spaces, or do I get a bonus from recycling in the taxes that I pay to the municipality, and these are stuff that are made available. But the citizens have no information about if this is in fact happening in cities. So
I guess it's a very common issue, at least in my part of the world.
Yeah. So the solution has to be. That's why we partially accepted, because we cannot say that the city communicates with citizens, so we cannot determine the influence of it, but we know that the citizen is interested in having this information to better participate in the city and to engage with the city.
Thank you very much, Rui, and we are now drawing the session to the conclusion for this slot. And the sixth and final slot will start at 11:30 and will be chaired by Chiara Galao. So we'll be on live in 15 minutes about. Thank you very much for attending. Thank you all.
Hi, there is someone online? There is someone online. Could you listen to me?
Yes, good morning. I can hear you.
Okay, I don't see you. Just 1 second. Ah, okay, perfect.
I'm here.
You are?
The first presenter, Diana Lopes.
Diana Lopez. Okay, perfect. You are alone. There is also the second presenter and the third.
Don't know.
We are alone.
Yeah, I guess.
We can wait 1 minute.
Okay, okay.
Okay. Where are you from, Diana?
I'm from Portugal,
Oh.
from the University of Aveiro.
Oh, so, okay.
So we have now, we have 3 presentations in this session.
Try to share the presentation and
Yes, I can try. Yeah.
If people doesn't arrive, we can start. Okay.
Okay.
Oh my God. Okay. 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 Yes, no, but the other one because. Oh, okay.
Can you see my presentation?
Yeah.
Okay.
So you are alone, so we can start and bring your time if you want. If you want, not only 10 minutes, but you have to present.
Okay, I have prepared my presentation to last more or less 15 minutes, but
okay.
If there are questions, I'm available to answer them. Okay, so I can start, right?
Yeah. Go on.
Okay, so I'm a PhD student in industrial engineering management at the University of Aveiro, and I'm going to present this study entitled "A Multi-Criteria Decision Analysis GIS-based approach for evaluating accessibility to health facilities," and this work results from the study developed with Professor João Marques and my supervisor, Professor Eduardo Castro. My presentation will follow this structure. So at first, I'm going to introduce the context and the objectives of this study, followed by the methodological framework. Then an illustrative example will be presented, followed by concluding remarks. Okay, so although the term access to healthcare is not a recent issue, only in the last decade has been an increasing effort to achieve the promotion and the monitoring of these objectives with the European Commission, the European Parliament, and the European Council, recognizing the access to healthcare as one of the pillars of social rights in Europe. So in this sense, it is critical to have a correct evaluation of the population's accessibility to health facilities, such as primary healthcare units or hospitals. And previous studies in this field have improved our understanding of the role played by spatial distribution of health facilities, with most of them using gravity-based models in which geographic information systems play an important role in the impact measurement. And basically, the original gravitational model results from a modified version of the Newton's law of the gravitation, and it generates an index of accessibility to each territorial unit that provides a joint measure of 2 components of access. The number of human health resources, typically the number of physicians that work in a health facility, that is represented by this variable S, and the proximity to healthcare offer points, considering the population they serve, that is represented here by this P and the distance by this D. However, given the computational and programming efforts that these type of models require, simple versions have emerged, such as the two-step floating catchment area methods that are represented here by this mathematical formulation. And these methods also generate an index of accessibility, but in this case, through the definition of a service area of human resources by a threshold travel time, while accounting for the number of human resources by their surrounding demands. And here you can see the typical outputs of applying this type of methods. So in this case, for each territorial unit, in this case for each Portuguese statistical section, we have accessibility score. So high scores are located in the metropolitan areas, Porto and Lisboa, so they are associated with high levels of accessibility, and low scores are associated with low levels of accessibility. And why are these methods widely used? Well, they are included in some geographic information systems, such as the ArcGIS software, so as it allows for intuitive use by producing an index of accessibility that allow us to measure spatial inequalities. And they are being recommended by some governmental health authorities, such as the Portuguese Health Regulatory Authority, enabling organizations to prepare convenient documentation. However, the users of this type of models should be aware of some key problems. So at first, these methods do not include all the dimensions of access. Typically, they just consider the proximity to healthcare locations and the number of human health resources that work in health facilities. And these criteria, these dimensions of access should be discussed with decision makers, citizens, and health professions, because otherwise the problem is formulated as if there were only one decision maker. Another aspect is that the scores that are generated are devoid of absolute meaning. That is, it is just possible to relatively compare the accessibility scores in different locations, but we cannot understand what is a good accessibility, what is a score that is, what score is recommended. And on the other hand, impact is seen as the same as value, and they may not be equivalent. For instance, the difference between 10 and 20 minutes of travel time distance between population and physician locations may be not equivalent to the difference between 20 and 30 minutes, depending on the perceptions or tolerance of different citizens and decision makers. So this type of conversion of impact to value can be obtained through the application of some multi-criteria decision analysis techniques that I'm going to explain later. Also, there is no reflection about the aggregation mechanism of the different criteria, if it should follow compensatory or non-compensatory rules, which all together can lead to suboptimal resource allocation. So, as mentioned in recent studies, gravity-based models serve as a good starting point to measure spatial inequalities, but their results are not intuitive and intelligible for decision-making purposes. So the challenge is how to evaluate and collapse impacts of multiple dimensions of access. And in this study, we propose the articulation of geographic information systems with multiple criteria decision analysis methods. And why multiple criteria decision analysis? Well, because they are based on sound theoretical foundations, allowing us to account for the multidimensional nature of access, for quantitative and qualitative levels of information of different criteria or dimensions of access, and to account for preferences or subjective information coming from different persons, citizens, decision makers, health professionals, through a social technical approach, and then supporting informed decisions. And which multiple criteria decision analysis method to adopt? Well, given the current pandemic context, it is important to adopt an MCDA method that requires a reduced number of judgments or preferences from decision makers, because our decision makers in our context are health professionals, health administrators, physicians, nurses, and they have limited availability. Hence, it is important to reduce the number of judgments. It is important that this method should be flexible to include not only ordinal but also cardinal information to estimate criteria weights and the value functions that convert impact into value, and that aids the process of collecting the subjective information or preferences without compromising the model accuracy and quality. So, inspired by the Utah Star method, we proposed here a new variant of this method that is based on a preference disaggregation model that infers one or more additive value functions and weights from preference data regarding a list of alternatives. For instance, the global value of accessibility of an alternatives, let's say of a primary healthcare unit, a health facility, is given by the sum of partial values of accessibility on each criterion, multiplied by the weight of each criterion. Okay, and to an alternative that is in the best impact level on all the criteria is assigned the value 1, and to an alternative that is in the worst impact level on all the criteria is assigned the value 0. Okay, so the activities involved in our framework proposal are here presented. So in the first activity, the structuring phase, it is important to identify and define the relevant criteria to appraise the population accessibility to health facilities, in this case, primary healthcare units. Then we have to operationalize the criteria and select the options of comparisons. And here, since this is not the focus of this paper, we select and identify these 3 criteria: general practitioners per 10,000 patients, nurses per 10,000 patients, and travel time distance between population and physician locations. And then we have to operationalize these criteria. That is, we should be able to measure and characterize the impacts of our alternatives in each criteria, and to select the alternatives of comparison that are primary healthcare units. So in this context, we have a reference set of alternatives based on real primary healthcare units, and a set of hypothetical alternatives that are selected to adopt a weighting protocol to estimate the criteria weights. Okay, so the next step involves the evaluation activity that we intend to gather preference information regarding the previous list of alternatives, and we propose here a questioning protocol that follows this logical. Consider the following socioeconomic context: low levels of income and high old age dependency ratio of patients. What is your preference regarding the following primary healthcare facilities? One that has 4.5 general practitioners per 10,000 patients, that is above the recommended value, according to the Portuguese health authorities. 2.2 nurses per 10,000 patients, that is below the recommended value, and 2 minutes of travel time distance. And another one that has 2.8 physicians, 5.2 nurses, and 35 minutes of travel time distance between physicians and population locations. And then we ask our decision makers to judge the difference in attractiveness between these two primary healthcare units based on these 7 qualitative categories, from null, very weak, weak, moderate, strong, very strong, and extreme. Suppose that our decision makers answer strong and that we collect other judgments between consecutive order alternatives. Then we are able to check if there are solutions compatible with this reference or subjective information by solving 2 linear programming problems that are here presented. If there is no solution, we can adopt a protocol that deals with inconsistencies. Otherwise, we can achieve and obtain utility functions that convert impacts into value, as you can see here in each criterion. General practitioners, nurses, and travel time, we can convert impact into value. And also we can obtain the criteria weights. In this case, regarding the preference information that I have shown in the previous slide, the most important criterion is the general practitioners per 1,000 patients. And based on this information, we can determine the global value of accessibility of our primary healthcare units and compare to the recommended values, that is here represented by this value, 0.7. And then we can represent these global values in a map, especially represent, sorry, especially represent these values in a map. Okay, so in conclusion, gravity-based maps are widely used, and of course they are a good starting point as they generate an index for measuring spatial accessibility to healthcare facilities and allow us to identify spatial disparities across different regions and to infer some relationships between accessibility and socioeconomic characteristics of the population. However, according to other studies, gravity-based models are seen as not intuitive and intelligible for decision-making purposes. And the articulation of geographic information systems with multiple criteria decision analysis methods seems to be a promising work to aid decision makers and to improve this topic. For the next steps, we are finishing the designing process of a web platform to capture the preference informations from decision makers and experts in order to evaluate the Portuguese population accessibility to primary healthcare units. Okay, so that's it. Thank you very much for your attention.
Thank you so much, Diana, for having presented your really interesting presentation. And I saw that there is also the second speaker. Jose Rodriguez, are you in?
Present.
Okay. Do you have any question about the presentation of Diana?
Not.
Okay. Okay, so we can go. Thank you so much, Diana. We can go to the next speaker, Jose Rodriguez. I'm sorry for my bad Spanish pronunciation. And he will present an integrated model for locating routing in the goods delivery and simultaneous pickup in the urban context. So, Jose, the floor is yours. Can you share your presentation?
One moment.
Okay, okay.
See? To see?
Not yet.
I begin?
Not yet.
Repeat, please.
We see your desktop, but not your presentation.
No está bien, no sé. ¿Cómo se hizo? Yeah, ahora sí.
Okay. Perfect. Thank you.
Okay. We can start. You can start, please.
Good morning. Good morning. My name is José Rodríguez Melquiades. I'm from Peru. My article, my paper is an integrated model for location routing in the goods delivery and simultaneous pickup in the context urban. So, the new model optimizes goods by integration, location, and routing. This process delivering and collecting goods and weights at the same time, and determines the consumption to the use fuel and measure the CO2 generation in the routing. So, location distribution center is an activity very important in the logistics systems.
Excuse me,
After,
but we can see the first slide. I don't know if you are speaking with the second or the third, but we see the first slide.
okay. After such location, it's possible to obtain a service on each customer by following a routing plan.
Rodriguez, we see the first slide. You can change the slide during your presentation.
Maybe you have to put in presentation mode because we can see only the presentation of your paper, the first slide. You understand me?
Okay.
Oh, perfect. Perfect. Okay, perfect. You can go on.
Continue?
Yeah.
So, locate distribution center is an activity very important in the logistics systems. After such location, it's possible to obtain a service for each customer by following in routing plan. It's important to integrate the facility location problem and vehicle routing. I have problems. Excuse me, I have problem with my laptop.
You can go on to speak. Don't worry if because we can see also the other slide in a really short framework. So don't worry, speak and don't worry absolutely.
Thank you very much. Ya casi avanza. Chingada. Porque me dijo que me podía esperar.
Okay. Okay, perfect. Oh, now we can see also your presentation.
Review. To develop the optimization model is what is necessary to know the following concepts. Concept about location, concept about location and sustainability, concept about vehicle routing, and concept about location routing. So the automation model has two function objectives. For objective one is about function optimization cost, location, and use vehicle. In the function two is measure general CO2 pollution during the routing process. With model a proposed model use the following in the case one following. In the table 2, information about location, supplier and facility. Supplier S1, S2, S3, and facilities F1, F2, F3, F4, F5, and location. In the table 2, information, location, the customer and their demands. 6 customer, location, and delivery demand, and delivery, and demand to collect. Results. The model implemented showing the following results. In the table 3, transportation from supplier to the select facility. In the table 4, the delivery of demands, products, and waste collection. In case 1 and 2, in other scenarios, 4 scenarios, to see in the scenarios 5 and 6, the process time exceeding the time limits. Conclusions. The paper show model the new integrated facility location and vehicle routing. It also model situation such as fuel consumption and measure of the CO2 emission in every road. The proposal is based on the premise that there is a set customer. This premise reduces the service and transportation costs. In the conclusion 3, the result show potential a new model proposed for a small number of customers. A critical aspect is with in scenarios with more 21 customers within the lifetime. That's all. Thank you.
Thank you so much. Thank you so much. Do you have any question, Diana? Oh, okay. So thank you so much for your presentation. And I don't know if there is also the third presenter. Spatial modeling of suitable distribution. No? So we can conclude this session. And thank you so much. And see you. There are other sections, no? see you for the next year in Malaga. Okay, bye.
Bye.
Thank you so
very much.
Thank you. Thank you.
I from Peru, sto molto longe da Italia.
Don't worry.
Thank you very much.
Bye.
Bye.